today we will discuss on this lecture conversion of finite automata to context free grammar and also regular grammar into finite automata. Already we have studied the context free grammar, what is the finite automata, what are the regular grammar, already we have studied. Now today we will discuss how this if your finite automata is given, how it convert into a context free grammar. First I will discuss on this, then after we will go to the regular grammar to finite automata. So, already we know that a context free grammar having 4 tuples, that is V, T, P, S. V is the set of variables you can say, and T is the set of terminals, and P is the production symbols. This production of symbol of context free grammar is V union T stars. So, you can see this context free grammar production. So, here it is, this is S, suppose A, B, then A to B, A and B. You can say these 3 productions are in context free grammar. These 3 productions are in, you can say this is a context free grammar. This B union T asterisk, this means T, B union T asterisk means there is in right side there will be the any combination of variable and terminal, right side any combination of variable and terminals, and the left side only one variable is there, then we can say this is a context free grammar. So, now S is the start symbol of the grammar. So, we know already know that this is the context free grammar production rules and these are tuples. So, if a finite automata is given, how to convert this finite automata to context free grammars. So, already we know in finite automata we have 5 tuples, capital Q which is the set of states, and in set of input alphabet sigma, and transition function del, Q0 is the initial state and F is the final states. So, already we know these tuples. So, your diagram if it is given these 5 tuples, then how will convert these to VTPS, variable terminal production rule and starting symbol of the context free grammar. So, here we have given a context free grammar G having 4 tuples VTPS and finite automata a machine M. Here is the 5 tuples, capital Q, sigma input alphabet, and del is the transition function, Q0 and F is the final state. So, here is the rule, if S is the starting symbol of the grammar, then Q S is the which is Q0 initial state of the finite automata. So, if a Q0 is the initial state of the finite automata, that will be the starting symbol of the grammar, that will be the starting symbol of the grammar. Then second one is saying whatever variables are there, whatever finite automata states are there, that is in variables. So, we can say all states in finite automata are variables. Then after we have sigma input alphabet, if whatever input alphabet in finite automata, these are terminals. So, we have some transition function in finite automata, these are we have to this transition function we have to convert into productions. Whatever grammar production P, all transition function will be converted into the productions. So, like that you have a context free grammar, if a transition function for every transition finite automata del capital Q and input alphabet and Q, then there is a production Q to input alphabet Q. Then every final state of in finite automata, there is a epsilon transition in your epsilon production in context free grammar. So, take an example here, we will do one example. Suppose one finite automata given, one finite automata is given, see here, suppose this is Q0, one is initial state and here it is B and here is the A and this is the Q1, and let make it final state as a Q1, then this is A and B, so A, B. So, now this is the finite automata diagram we have drawn. So, how this finite automata diagram will convert into to CFG, context free grammar. So, already we discussed that all states in finite automata that will be belongs to B. So, here context free grammar we have we already know context free grammar we have grammar having 4 tuples V, T, P, S. So, now see in this V it will be Q0, Q1. So, Q0, Q1 is the states of the finite automata that will be is in V set. Then after we have input T terminal. So, terminal you can check what are the input alphabet in finite automata. You see in capital Q is Q0, Q0, Q1. Then input alphabet is this is input alphabet is A, B. So, now T having A, B. So, this is the now what is the S? S is the starting symbol. So, here initial state is Q0, initial state is Q0, initial state is Q0. So, S is the Q0, S is Q0, Q0 is the initial state. So, now we have already taken our V, T, S, only remaining the production. So, only remaining the production already we last slide we discussed that if a product transition function is like this capital Q, then input alphabet then goes to Q, then there is a production Q input alphabet Q, then Q to input alphabet capital Q. This is the production rule, this is the transition function and this is the production rule, transition function to production. So, now we have to convert this production, this transition function to production. So, what are the production will be here? You see here what are the production here. So, P first you check it Q0, there is a Q0, there is a input B and going to Q0. So, first production will be Q0 and this is B Q0. Okay. Now, we have another state in Q0 input A going to Q1. So, another production will be Q0, this is A and Q1. So, now we have Q1. In Q1 you see in Q1 input is A and going to Q1 itself. Then Q1 this is B and Q1. So, another rule is there, every final state there is a epsilon production. So, here Q1 is the final state. So, Q1 and this is epsilon. So, now we have converted this finite automata to context free grammar. We have already converted this finite automata to context free grammar. So, here Q0, Q1 is the V variables and A, B are terminal, whatever input alphabet in finite automata that is in terminals, and here is the Q0 is the initial state and production is Q0, B Q0, Q0 A Q1 and Q1 A Q1 and Q1 to B Q1 and Q1 to epsilon. So, these are productions. So, here you can check whatever string accepted by the finite automata also it is generated by this context free grammar which we got it. So, here you can take one string, suppose A B is accepted by this finite automata. Take an example string A B. So, suppose string A B, the string A B is accepted by this diagram, accepted by finite automata, accepted by finite automata. So, now from the grammar also we can have this string. So, we will start draw a parse tree, you will check it, suppose we will draw a parse tree here, you see here Q0, in Q0 you have a transition, this is A Q1, then Q1 there is a transition B Q1, then Q1 to epsilon. So, now we got here AB as a string from this grammar. So, like that we can convert all the DFA or all the finite automata to context free grammar. So, this is the process for finite automata to context free grammar. So, now we have another regular grammar. If a regular grammar is there, then how we convert into finite automata. So, already we know if a regular grammar or regular expression or regular language it is given and finite automata. All four are similar. If a finite automata is given, we can convert into regular expression, we can get in regular grammar, we can also we can have regular language. If a regular language is given, we can have regular expression, we can have regular grammar, also we can have finite automata. So, here it is another topic that context free regular grammar to finite automata, regular grammar to or regular language or regular grammar, we can have a finite automata. So, here we have a regular grammar G and can be converted to a, we can have a finite automata to accept all string generated by the grammar G. Here it is written let L is a regular language, then we can have a regular grammar. So, already we know if a regular language is there, we can have finite automata. So, we can have a regular grammar. So, we converted from regular language, then we can have a regular grammar, then we can have a finite automata that accept all string generated by the grammar G. So, what are the rules to convert regular grammar to finite automata? So, here every production A to AB, then there is a transition A finite automata, this you can say this is A, B are variables. So, now this is in finite automata, these are the states. So, here capital A is a state and input alphabet is A, then going to B states. So, another rule is saying every production A to A, there is a transition A to final state. So, here it is saying that if a production is deriving only single terminal, means single terminal, this is capital A to small a, then there is a transition, you see there is a transition finite automata A to F, means here A is a state and A small a is a input alphabet and go to the final state. If this type of production is there, you have to make it the final state. So, now every production A epsilon make A as a final state. Suppose any production is there, it is giving the epsilon transition, we have to make it final state. So, this is the rules we have to convert to finite automata from a regular grammar. This through using these three rules, we can have finite automata from a regular grammar. So, let us take an example, we will take an example and check it how this is converted to finite automata. Suppose one regular grammar is given. So, here I have taken an grammar, you see here this is a regular grammar, you can say this is a right linear regular grammar. So, A to BB, now B to BB and B to epsilon. So, let us take this grammar we have taken. Now, we have here is the V is A S A and B, and here input alpha terminal is this is A and B. So, productions are S is the starting symbol, S is the starting symbol of the grammar, starting symbol, and productions are these are productions means here S to AA and A to BB, then B to BB, then B to epsilon. These are productions. So, this grammar represent VTPS, variable and terminal, and this variable terminals, starting symbol and production tools. So, this is T. So, now we have to convert, already we have seen the rules. What are the rules I discussed in previous slide, that if all production S to A, there is a transition from A to, see here I am writing here, suppose S is the state which is a starting symbol, make it initial state, and here we are taking input as A goes to capital A. So, now we have input is A, there is a from A to B. So, now we have from A input is B, then this is B. So, again we have B input, B derive small b. So, when you are taking input B, then again come back to B. So, now B epsilon. So, another production is there B epsilon. So, if a variable derive only epsilon, then make it is final state. So, this is the conversion from regular grammar to finite automata. So, already we have discussed that this a production is there, Q input Q is the input alphabet, suppose this is Q, then if a grammar production is like this, then you have to, or you can say this is V to T V, then what will be there? Here is the V T V. So, this is the rules for each production, this is the rule for each productions. So, if we have some epsilon production only, then you have to make it final state. So, take an example string here. What are the string generated? Take example, a string generated by the grammar. So, here we can take a string is A B B. This is A B B, which is derived by the grammar. So, how this is derived? S to A, then A to B, then B to B, this is B, and B to epsilon. This grammar derived A B B. So, how this A B B is accepted by the diagram of NFA, whatever, sorry, diagram of finite automata. So, now you check here we have string ABB, we have string ABB, then here we will start here ABB. So, we can read here S to A, then goes to S to A, then we can have A, then A to B, then we can have B, then B to delta B to B, again we can have B. So, now B to, now see this is accepted, B is the final state, B is the final state, and this is accepted, this is accepted. So, we have whatever regular grammar is given, for that we can have also finite automata. So, here we have seen already that from a finite automata to context free grammar, or finite automata to regular grammar to finite automata. So, these two are covered. Now, we will see some questions given. Suppose one like the in GATE or some exam, it is asking some MCQ. I will draw the question diagram. So, suppose this is A is the initial state, and this is the A, and this is the B, and this is another is capital B, and this is B, and this is final state, and here is the B, and this is A and here is the suppose this is C and make it AB. So, question is given, option here given, this is a 4 option is given to given a grammar, suppose A2, A2, A, then A2, B, then B2, B and B2, A, then B2B, let us let me erase this one, this is the questions. So, now see B2B and B2 this is C, B2 this is C and AB, then after C2 AC and C2 BC and C2 epsilon, one question, one option A. Then option B is given S2 AA, S2 BB, A2 sorry this is A to B, then B2 BC and B2 A, then C2 A C and C2 B C, and then option C is given A2 A B and here is the B2 B C and this is A and C2 A C and this is B C and C2 epsilon, and option D is given none. So, you can identify which options are correct, from this finite automata to context free grammar. If you will see, there is a transition you see here in option A. Why option A is wrong? Why it is wrong? Here is the given that B to AB, you see here is the B to AB1 production, this is wrong, B to AB will be not there, and B2 there is a transition from B input alphabet A goes to A. So, here this is wrong, that is why this option is wrong. So, here you can check in option B. In option B we have here we have not taken C to epsilon. In our rule, every final state there is a epsilon transition, there is a epsilon production. So, it must be C to epsilon, it is all productions are right, but C to epsilon is not there, that is why it is wrong. So, now you can check A to AA, B to BC and A to B to A, AC, and every production here are right, and also C to epsilon. So, also then this one is very right, you can say this option C is the correct. So, in your GATE exam or any other exam, you will find this type of questions, some regular grammar is given, some finite automata is given, you have to find the grammar like that 4 option will be given that to you, which options are correct. So, like that you have to find the grammar. So, similarly if question is given, another question will be given that sometime a grammar will be given, you have to find the finite automata. So, grammar is given, suppose here is a grammar, I am writing another questions here. So, grammar is given, you have to given the options which automata is correct. So, like that suppose one question is there, suppose here question is given Q0 and this is A and this is B and this is sorry, grammar is given. So, you have to take a grammar, from grammar we have to find the finite automata. So, grammar is given, suppose this grammar is given S to A and A to A and this is A to epsilon, A to epsilon. Suppose this grammar is given, how to convert the finite automata? Suppose let me draw the finite automata. Is option A is given, option A is given that, so this is Q0, sorry S, this is S, S is the initial state. So, we have to take S, this is S, then we have A to A, this is A and this is A. So, now we have again A to A. So, this is one diagram. Option B is saying that S, S and this is A and this is A and make it final state and A, this is A and here you can say, suppose this is option A, then option C is saying this is S and this is A and this is A and here is the A and here is the final state. So, D is saying none of this, none of the D is saying none of this. So, if you will see this grammar, from this grammar you can say which options are correct. So, if you will see that here all the string at least A, then after any number of A will be accepted. So, this is the option B is the right answer, because here is the A must be final. In every production A to epsilon, that will be A as a final states. That is why this option B is correct. Option A never be correct, because S is not final state, because S do not have epsilon production. So, that is why option A is not correct and C also not correct, both are final state. Only A have epsilon transition, but S have no epsilon transition. That is why this option C also wrong. This is option A is wrong and option C is wrong. So, option B is right answer. So, here we will find some multiple choice question in GATE, some grammar will be there and some contest finite automata will be there and you have to convert into grammar, and some grammar will be there, convert to finite automata. Like that you can do some questions. So, these are references book. Thank you.